Hey guys, welcome in this movie of paragraph 7.2 exponential growth. And then we're talking about the growth factor and we're talking about how that works. And first of all, let's take a look at the notes over here. And these notes, please copy them. And then I'm going to explain them with a calculation, with an example with the COVID-19 situation. Why they are having such a big deal about the R-getal or reproduction number. Now, you can have a growth process that you grow, and it is called exponential when the factor by which you multiply per unit of time remains the same. And so that if we, for instance, start with 10 and each day we multiply by 2, so each day it gets doubled. Then you start with 10, next time it's 20, and then it's 40, and then it's 80, and then it's 160, and then you can see it starts to grow slowly and it rises quickly and quickly and quickly. And that is called an exponential growth. And that growth factor is then, by definition, the new amount divided by the original amount. When I was multiplying by 2 each time, the original amount was 10, multiplying by 2 is 20. Then for the next step, the original amount was 20, multiplied by 2 to get 40. And then for the next step, the original amount was 40, multiplied by 2 is 80. And an exponential growth can also decrease instead of increase. You could also have a growth factor of 0.5. If we then start with 10, you multiply by 0.5, and then you have 5. And then next time you have 5, you multiply by 0.5, you have 2.5, and so on and so on. When the growth factor is greater than 1, it increases. When a growth factor is between 0 and 1, it decreases. That's why we also said if the growth factor is 2, it went up and up and up and up. And if it is below 0 and 1, it was half, then it went down, and then it quickly goes down, and then gradually starts to peter out a bit. And it's decreasing less and less quicker. Okay. How's this working? Well, as you know, I've got the website, the official website of the the corona dashboard, and then is that reproductiegetal or R-getal, the R, the reproduction number. And you can see over here right now, it is 0.98. And what is that? That is the amount of people that get infected by someone else. So if you have corona, on average, how many people will you infect? That will then be 0.98. And if we take a look at that, that's basically the growth factor. You are number 1, then the amount of people you infect is multiplied by 0.98, so that is 0.98. They will infect 0.98, so multiply by 0.98, and so on and so on. And you can see that the growth factor is between 0 and 1, so it should go down. So basically this R number is the growth factor. And then if we take a look at it, we have the COVID-19 situation, and we are talking about the British mutation. And the British mutation has a slightly worse that you are infected more quicker, and the growth factor or R-getal of the old version is now 0.98. We will calculate with 0.9. It's a little bit easier. And the R-getal of the British mutation is now 1.3, so it is more. And we will calculate how many people will be infected over time if we start with 100 persons. So if we start with 100, that's easy to calculate. And we start with the old mutation. Okay. And then we have over here, we have the time. And here the infected. How many people are infected? Okay. And at the start, at 0, we have 100. And with the old mutation, we calculate with 0.9. So we each and every time need to multiply by 0.9. So if we have 100, we go to 90, that is at 1. And then we can go to 2 and 3 and 4. Okay, and then with 2, we need to multiply by 0.9 as well. And then we need to multiply by 0.9 as well. 0.9 multiplied by 90 is 81. And we multiply by 0.9 again. Then we have 72.9. And then we multiply by 0.9 as well. And you get 65.6. And if you continue, you will see that it goes down and down and down. You get less and less and less. And then in the end, you will get very close to 0. And that is what we want to. But how does it work out with the R value of the British mutation? So here we have the British one. We have the time again. And the number of infected people. Okay. Then we start with 0, 100. And then we multiply by 0.3. Okay, and then we need to do that with 2 and 3 and 4. And then we need to multiply again by 1.3, multiply again by 1.3, and multiply by, you know it. Okay, so we start with 100, multiply by 1.3 is 130. If we multiply it again by 1.3, we have 169. And I multiply again by 1.3, 219.7. Multiply again by 1.3, and then we already have 285.61. So you can see it quickly grows. So here we have an example of a decreasing exponential growth. The growth factor is between 0 and 1, and it goes down at the end less quick than in the beginning. And here we have an exponential growth where it's increasing, the growth factor is greater than 1, and you can see that the number first slowly goes up, but then it goes the amount gets bigger and bigger all the time. And what I would like you to do, I would like you to try to calculate the growth from 0 to 5 if we have an R value of 0.6, and that is the value they have in England right now with very strict, and I want to with very strict things that you can't do anything anymore, and very strict restrictions. And I would like you to start with 100. Okay, see you in class, and bye.